Okay, picture this. Robots that can think, see, and act, solving really complex problems right there in front of you. But here's the kicker, all without needing Wi-Fi. No cloud connection. Like zero internet required. It really sounds like something out of a sci-fi movie, doesn't it?
It really does. But what we've been digging into, the sources we've gathered for you today, they show it's very much becoming our reality.
Yeah, it's kind of staggering.
It's not just here. It feels like a foundational upheaval in how we even think about intelligent machines
Yeah,
and, where that intelligence actually lives.
absolutely. So today we're taking a deep dive into DeepMind's really groundbreaking work. They call it Gemini Robotics on Device.
Hmm.
And our mission here is to unpack this pivotal evolution in AI. We want to understand not just what it is, but really why it's such a massive leap for robotics and, what it means for all of us down the line.
Yeah, we'll try to cut through the noise and pull out the key insights from the material we reviewed. And, as we were looking into this, what really jumped out is how this whole development sits right at this exciting crossroads where embodied AI meets edge computing and this thing called VLA fusion. These are concepts we'll definitely explore, but they basically allow intelligence to, well, live right inside the physical robot itself, not far away in some data center.
Okay, so intelligence lives inside the robot. That's a powerful idea. How would you start breaking down what Gemini Robotics on Device actually is? Why is it so different?
Well, at its core, you can think of it as a compact, multimodal AI system. But the really critical difference is that it's trained to understand and execute complex physical tasks based on what it sees, visual cues, and also human instructions. And it's all of this within the robot.
Right there in the hardware.
Exactly. So the robot isn't constantly, pinging some distant server, sending data, waiting for instructions back. It's making its own decisions right there on the fly.
Wow. That sounds incredibly self-sufficient, and I gather it comes from DeepMind's bigger Gemini models like 1.5 and 2.5 Pro, but kind of specialized for robots.
Precisely. It's like they've given the robot its own specialized, super efficient brain, and it really boils down to four core capabilities that give it this on-device autonomy.
Okay, what are those?
So first, there's visual perception. It has to identify objects, understand the layout of a room, spot obstacles.
Yeah,
See the world.
makes sense.
Then language understanding. It needs to comprehend natural instructions, things like, hey, fold this shirt or organize these tools. Simple commands for us, complex for AI.
Right,
After that, it has to translate those commands into movement. That's motor planning and execution,
right.
figuring out the precise physical actions.
And the fourth one, that's the real game changer, isn't it, compared to older robots?
That's the one. The fourth is offline operation. This means it runs entirely locally on the robot's own hardware. No need for external servers, no internet connection.
No Wi-Fi, no cloud.
No problem. It's completely self-contained.
And the sources we read mention it's handled some tasks that sound simple, but are actually incredibly tricky for robots. Things like unzipping jackets, folding clothes, organizing stuff, even working in places it only partly knows.
Yeah, those are deceptively difficult.
What makes those specific things so hard for an AI? And what does tackling them tell us about the system?
That's a great point. Because these aren't just about, simple robotic arm movements. They need really fine-grained motor control, dexterity, and understanding context, all happening in real time. Think about unzipping a jacket, the precision, the force control needed, adapting to the fabric.
Yeah, I can see how that's fiddly.
Exactly. The fact that it can manage this stuff on device shows a remarkable level of, real-world intelligence and understanding why it can do them. That takes us to the architecture, how they've actually built it in simple terms.
Okay, so let's get into that. How do they cram all that intelligence onto the robot itself? What's the simplified version?
Well, it sort of starts with a sensor fusion layer. This basically pulls together data from all the inputs, cameras, microphones, maybe even touch sensors, haptic feedback.
So it gets a rich picture of what's going on around it.
Precisely. A holistic understanding. Then, this complex data gets fed into what they call the VLA core. VLA stands for Visual, Language, and Action. This part combines embeddings, think of them as numerical fingerprints, for images, words, and actions, all drawn from that base Gemini model.
Right, so it's processing sight, language, and potential actions together.
Exactly. From there, a policy module steps in. Its job is to choose the best sequence of actions based on all that rich, multimodal input.
Okay, deciding what to do next.
Yep. And finally, there's an embedded execution engine. This is highly optimized for doing the AI thinking, the inference really fast, right there on the robot's chip. That's what makes a robot actually move and act.
What I found really helpful from the sources in terms of understanding the how was the way they compress everything. The whole model gets squeezed down, quantized, I think was the term. So it performs well right there on the robot. The source compared it to how Gemini Nano runs on Pixel phones.
Yeah, that's a great analogy.
It makes it relatable, like having this AI powerhouse that fits in your pocket but now scaled and tuned specifically for a robot's body and tasks.
It really highlights the technical achievement. So, okay, let's connect this to the bigger picture. Why does this matter so much? If you think about traditional robots, the ones maybe more common today, they often lean heavily on cloud processing,
Right, constantly sending data back and forth.
which means high latency delays, dependence on the network. They're not always super adaptable, and they're vulnerable. If that connection drops, Wi-Fi goes down, your robot might just stop or get really sluggish.
Yeah, not ideal. But with Gemini on device, it sounds like a totally different world.
It is. You get fully self-contained thinking and decision-making. Latency is near zero, so it's responsive in real time. Plus, it's flexible, it can follow general instructions, and, as we keep saying, it operates without any connectivity. Total independence.
So it's not just an upgrade, it feels more like a decentralization of the AI's brain, moving the intelligence from those big cloud servers directly into the robot.
That's a perfect way to put it, and that fundamental shift changes everything. Privacy, energy use, where you can even use these advanced robots.
It's like, remember when feature phones first came out? Suddenly people in remote areas could communicate? This feels similar for robotics.
Exactly. It opens up completely new possibilities. Think about warehouse automation networks there. It can be flaky.
Right.
Or assistive care for the elderly in their homes. You want privacy and reliability.
Or space. You can't exactly rely on cloud connection in orbit.
Or space, absolutely. Search and rescue in disaster zones, too. Places where cloud access is impossible or just too risky. Anywhere you need that offline autonomy, it's not just nice to have, it's essential.
You can easily see the ripple effect across industries. Healthcare, manufacturing, logistics, maybe even consumer robots eventually. Defense, disaster relief. The applications seem huge.
And a really crucial piece here is reducing that dependence on the internet and big data centers. That inherently improves privacy, it's more energy efficient, it's faster, and importantly, it makes AI robotics potentially more scalable, cheaper, and deployable anywhere in the world, even places without robust infrastructure. That's huge for real-world adoption.
And this all seems to plug directly into DeepMind's bigger vision, right? They've been talking about this for a
For
while.
a long time, yeah. They've envisioned robots that understand us, see and feel their environment, and act safely and independently in all sorts of settings.
So this isn't just some cool lab demo.
Now, this feels like the first major public demonstration of that whole integrated vision, actually moving out of the research phase and into, well, practical applications.
Okay, but it can't be all smooth sailing. What are the challenges, the hurdles they still need to overcome?
Well, definitely challenges. Hardware constraints are a big one. Squeezing these powerful models onto robot hardware without losing too much intelligence or responsiveness, that's tricky.
Right, the compression can't make the robot dumb or slow.
Exactly. And then there's error correction in the real world. It's not like a simulation where you just hit reset.
Good point. A real-world mistake could actually break something, or worse.
Precisely. If a robot makes a mistake in the physical world, it can be damaging, sometimes irreversible. So handling errors gracefully is critical.
And what about learning? Does it need tons of data for every little task?
That's another key challenge, data efficiency. Ideally, these robots need to learn effectively from just a few examples, a few demonstrations, and adapt quickly to new things, not require massive data sets for every single skill.
That makes sense for practical use.
And then there's safety and interpretability. You have to be able to trust these autonomous decisions. You need to understand why the robot did what it did, especially if it's working around people or in critical situations. We need ways to audit and trust those on-device choices.
So, given those hurdles, but also the massive potential, what's next? What's the roadmap look like?
Well, based on the sources, we can probably expect to see more partnerships. Collaborations with robotics companies, maybe like Boston Dynamics or Everyday Robots, to get this tech into more platforms.
Integrating it more widely.
Yeah, and also pushing the capabilities further. Expansion to understand multiple languages, handling more complex multi-step tasks, and likely integrating it more deeply with reinforcement learning so the robots can learn and adapt better on their own in changing environments.
And what about us? Any chance we see this closer to home?
That's the intriguing bit. The sources hint at the potential for consumer versions, maybe features integrated into future Pixel devices, or perhaps even dedicated Google Home robots someday. That's still speculative, but it's on the horizon.
Fascinating. So if we zoom out one last time, the big takeaway here, it feels like Gemini robotics on device really marks this fundamental shift. We're moving towards intelligent, general-purpose robots that understand us, act on their own, and don't need the cloud to do it.
Yeah, it's a major leap for edge AI in robotics.
And it definitely seems to cement DeepMind's position as, a major player racing towards these safe, smart, deployable AI machines.
It absolutely does. And it leaves us with a pretty big question to chew on, doesn't it?
Which is?
Well, what happens when these truly autonomous offline robots become widespread? What does that mean for how we share spaces? For our personal privacy? How does it even change what we mean by assistance when intelligence is truly embedded everywhere around us?
That's definitely something to think about. A future where intelligence isn't just out there in the cloud, but right here, inside the machines around us.
It's a fascinating and maybe slightly unnerving future to imagine.